Hello everyone, and thank you for joining me. Our EIGRP video series wouldn't be complete if we did not talk about EIGRP with regards to IP version 6. Now, up until this point, we talked about how EIGRP works in dealing with IP version 4 prefixes. We talked about how to build an IP version 4 routing domain using EIGRP as our internal gateway protocol, or IGP. So I'd like to take a moment and discuss how EIGRP works when dealing with IP version 6 prefixes. And you'll be surprised to know that the features are essentially identical with some slight differences that we'll cover in this video. Okay? To do so, we had to role play again. So I had to modify the topology that we've been using up until this point. So the internet devices now have a public IP address space, and I've also configured the appropriate subnets with their corresponding IP version 6 public address space, and I've subnetted them accordingly. If these IP version 6 addresses don't resonate with you, please refer to the IP version 6 routing video that I created prior to this video. Okay, so why don't we go ahead and take a look at the configuration. So let's focus on Acme Edge 1, for example. To instantiate or ignite the EIGRP motor to be able to route IP version 6 prefixes, or to be able to create an IP version 6 routing domain, you need to turn on IP version 6 for EIGRP. This is the equivalent of router EIGRP 1528, like in the previous videos. This command enables IP version 4 routing domain. This command here initiates or instantiates the capability to be able to create neighborships via IP version 6. Now, what's interesting is that when you do turn on the IP version 6 motor, the one commonality it has with the IP version 4 version of EIGRP is that it leverages the IP version 4 IP address space for its router ID. So when it's sending out its updates and when it's starting to build a topology table via IP version 6, it's still leveraging the IP version 4 loopback address, the highest loopback address, or the highest IP version 4 physical interface as its router ID. Another difference is that in IP version 4, under the router EIGRP 1528, we would then use the network command to be able to announce out that particular or any interface that pertained to that subnet. Do you remember? Well, in IP version 6, it doesn't work that way. In IP version 6, you enable the interface by using this command here, IP version 6 EIGRP 1528. So basically what you're saying is that this interface can create a neighborship, an IP version 6 EIGRP relationship on this interface, as opposed to in IP version 4, you would use the network command. Okay? Now, what's also interesting is that in the IP version 4 topology that we talked about earlier in the previous video series, as part of this video series, is that there was a static route. There was a static route that was pointing out in this direction to be able to reach the IP version 4 address that was associated with the internet devices here. Okay? Now, to accommodate that match under the IP version 6 address family, we use this particular command here. This is how you would write a default route with its next hop, IP version 6, in under the IP version 6 address family. Now you can see how this process continues under all the routers. So I do the exact same thing and I accomplish the exact same task under all the routers. And I enable IP version 6 neighborships under each and every interface, matching it with its IP version 4 counterpart. Okay? Now, we get to Acme Core 2, which is this router right here, and Acme Stub. Now, as we know, because we're familiar with this topology, these routers here have a particular role because they're directly connected to the access layer. So how do we apply the passive interface and the EIGRP stub commands just like in IP version 4? Well, the exact same way the exact same way in IP version 6. So under IPv6 router EIGRP 1528, you would just leverage the exact same command under the IPv6 router EIGRP process. The same goes with the Acme stub. And you would add the passive interface as well as the EIGRP stub command. So, having gone through this configuration, and feel free to pause this video and take a look at the configuration, or if you have the opportunity to even rebuild this topology in companionship with myself, go ahead, I encourage it. But what I'm going to do is I'm going to stop the video, I'm going to apply the configuration, and then we're going to take some packet captures and see how it behaves. All right, so I've just applied the configuration, and I'd like to take a look at of what we've currently accomplished here. So essentially, we have all the features that were applied in the IPv4 EIGRP routing domain, we have replicated in the IPv6 routing domain. So we have the passive interface down here, and we are also announcing out the IPv6 subnets. We have the static route pointing to SHA with the redistribution of the static route into the core EIGRP IPv6 routing domain. We have this Acme stub that is currently announcing out the IPv6 prefixes of the access layer. And we are also performing a passive interface downstream to prevent EIGRP neighborships happening in the LAN environment. So it's a very similar setup, okay? It's a very similar setup. However, what needs to be understood is that we have two completely different address families, all right? So what we need to kind of grasp here, all right, because I'm going to make this line really thick, is that we have an IP version 4 domain, which is routing IP version 4 prefixes using the EIGRP protocol natively, okay? But we also have created an IP version 6 address family based on EIGRP that is layered on top. So we have two instances or two completely different EIGRP protocols, right? Even though they're identical, they are routing two completely different address families, okay? So that's a very important point, because if I do this, and let me just thin this line out a little bit, because if I do this and I go to router edge, for example, and I do show run begin router EIGRP, you can see that this is the section that is dedicated to establishing IP version 4 EIGRP packets, and you can see that this process is a completely different EIGRP process dedicated to IP version 6 prefixes. Okay, so when you are troubleshooting an EIGRP environment and you happen to find yourself in an environment that has a EIGRP environment that's routing two address families separately, be cognizant of this, because even though they're identical in terms of features and functionalities and design and everything, they could also be possibly different. Because if I put a passive interface downstream in IP version 4, but I do not do it in IP version 6, that's a problem. All right? So you can see that as the network scales, if deploying EIGRP in your environment and you have two address families, this can be an administrative overhead. Okay, it takes a lot of administrative work to keep track of what was done in the IP version 4 routing domain and what was not completed in the IP version 6 routing domain. So that needs to be understood. The second thing that I'd like to mention is that in the IP version 4 routing domain, neighborships, okay, adjacencies, EIGRP adjacencies were done on the physically bounded interface. So the IP address that was physically bounded to this interface or configured on the interface, right? Okay, so if this was a 10.110/30 subnet, this was .1 and this was .2, the neighborship would be done on .1 and .2 using the multicast address of 224.0.0.10. We covered this in the previous videos. In IP version 6 is different because remember, in IP version 6 they have what's called the link local address. And the link local address, okay, which is a non-routable IP version 6 address, is a link local that is dedicated to these neighbors that speak IP version 6 and are allowed to send neighborship information between each other. Okay, as a matter of fact, if we do a packet capture, which I think would be the best thing to do here, oops. If we do a packet capture, you can see that the packet captures are different because in IP version 4, so EIGRP, in IP, let's see. So in IP version 4, you would see that the neighborships and the hello packets are being sent on the private IP address space that has been configured on the physical interface. Whereas in IP version 6, it's using the link local address. It's not using the unique local, which is the equivalent of the private address space in IP version 4. It's using the link local. And we're going to see this theme play out when we move into OSPF or any other type of interior gateway protocol that supports IP version 6. And this is a perfect example of what the link local IP version 6 address is used for. It's used for sending neighborship information that is private between the two network nodes or routers or switches that speak IP version 6. And that's what the link local address space is used for. And this is a perfect example. Okay? All right, so let's go ahead and attempt a ping. Okay, so I'm just going to go on VLAN 44, for example, and let's try and ping the IP address of here. And there you go. You can see that I have just created connectivity between this PC and the PC out on the internet. So we just have internet routing, okay? If we go to if I do show IPv6, I'm gonna grab, actually no, I'm gonna go to VLAN 88 because it's on the other side. If I do a show IPv6, and I grab this IP, and I go over to, and I do a ping from VLAN 44, I also have connectivity. So I also have connectivity from this particular PC down to here. So I have intra routing domain and I have access to the internet. I hope you enjoyed this video and please share, like, and subscribe. Thank you.